new version of this integrated development environment. It's version 1.5. G-IDE is Gator Integrated Development Environment for the GCPU. So I think officially it's the G-CPU IDE, Integrated Development Environment. Written by Zachary Ut, G-IDE. First thing is it's going to work not so unlike the integrated development environment that we use in microprocessors. In fact, what Zachary did is he modeled it after what we use in micro-P, which, they all work kind of the same. Integrated development environments kind of all work mostly the same. So first, I have here, I make a new project, and I've already made a project. It's called here G-IDE full. So I'm not going to make another project now, but you make a project, and inside the project, you have what's called solutions. And what I suggest you do, you make one project, and that's all you do for the semester, and then you'd have different solutions for your different problems that I asked you to do, make the different solutions. So I made a project, and I just call it G-IDE full. And I've already made one, and I'm just going to open that first, called TT123. Just a kind of a really simple little program. Okay, let's look at what this program does. First, it has for 1000, and then run sum, ds.b. This is a variable, as opposed to dc.b we had in the phone number example. That's for constants. This is for variables. This is a 1-byte variable. And run sum, this is going to have a running sum of something I'll keep in a loop. I'll keep adding some value to some other value. So here's my program. Again, always starts at address 0. I'm going to load a decimal 37 into A. Then load a hex 37 into B. Then add A to B. Then I'm going to store the result, which is now in A, into this running sum, which is at address 1000. And then I'm going to run it again. Now, branch not equal. So as long as A is not equal to 0, I'll keep running this. And I think you probably have to add about 100 times before it's equal to 0, and I won't get to there. So, but it could, in fact, get past there. And if it did, we would probably want one more line at the end, which would be something like range equal. Let's just call it done and done. Okay, so now we have a complete program. So now, what can Mini-IDE do? So it allows us to write a program, but it also allows us to assemble a program. So this little symbol right here, you move your cursor on it, it says build assembly. I'm going to click on it. Look down at the bottom. It said build initiated. It says the file is tt.asm. Our assembly language files will always be something.asm. At least when you write it in a typical assembler, that's what we typically use. And then it actually created a ROM MIF and a RAM MIF. The same ROM and RAM MIF that you'll need for Lab 7. You'll have a ROM and RAM MIF. You're making a MIF file in Lab 6 as well. And it's created those. In fact, we can go over here and look at those MIF files. And I'll look at that in a little bit, but not quite yet. So now we've written this. How about let's run it? We can simulate it. So over here, right here, this button right here, if we put the cursor on it, I'm trying to, that was basically, this says run. And I don't know why it didn't say the word run, but that little arrow, that runs the program. And notice how it got kind of grayed out. So we're ready to kind of run the program. It actually started running. So up here, this is called Project Explorer. And this is what it's called in the integrated development we use in micro-P. And then here it says Register Explorer. Let's click on this. Well, look at that, A and B and X and Y. Program counter, the Z flag and the negative flag. These are all the things that the special registers that we have in our GCPU. Those are already there. And I've already, let me get rid of these temporarily, so I'll add them back. So I'm going to add here, this is called the Watch Explorer. So you can watch certain locations. And so I'm going to say, hey, run sum. I want to watch that location. Then on that location, it tells you value. Value is the address 1000. And then what's at that location? Right now it's a 0. No particular reason, but before you run, usually all memory locations, all the registers are 0. Okay, now if I wanted to, I could just write the number 1000. And it'll be exactly the same. But you can use labels or you can use numbers. So now we want to run the program. Now, if you hit this little run button again, so it says start continue, it's going to start running. I don't want to run, I want to do this button, and this says step. So I can run one line at a time. So let's run, once I run this first line, what we should see is the value of A should change to this decimal 37. So let's do it. Oh, look at that, 25. Well, is 25 in hex, decimal 37? Well, you can always figure that out by doing this. Go to view and change the hexadecimal display to decimal. Oh, look at that. Now it's 37, and all these other things that were hex numbers are now decimal numbers. Look at the program counter. It's at 2. Why is it at 2? Well, it started at 0 because of this line. This takes 2 addresses. So this is now at address 2. So if I say step again, B now has, well, let's change this back to hex. B now has the decimal, the hex 37. So these 2 first lines are run, and we see that. Then it says add B to A, put the result in A. Let's run that. Well, turns out hex 37 and decimal 37 is 25. Add those together, you get 5C. So A is equal to 5C. You see that up at the top. Okay, and now we want to take that number that's in A, the 5C, and store it in this running sum. And so right now, running sum still has a value of 0. 1000 has value 0. Let's run that line. Well, look at that, 5C. And then I can do another step. Now, the negative, this says branch if not equal to 0. Look at that, the 0 flag is not set. The program counter, let's look at the program counter, is at 0008. The address right here must be 8. So when we step again, the program counter is going to get us whatever here is. So let's go back. And now look at that. The program counter is 4. So this must be the address of this here. And I can run it again. I can keep doing this, put the new value. The new value is now 93. But I can also put, here I got this little dot here. I can have this dot. This is called a breakpoint. I'm going to put the breakpoint here. And so I can run until the breakpoint. And so rather than single step, which is this thing here, I can run to the breakpoint. And so I'm going to run to the breakpoint. So now let's look at what's in memory here. CA, now I'm going to run to the breakpoint again. Now it's 1. I added to CA hex 37. I keep doing this, and you see it keeps changing. Oh, you saw the negative flag went true? Why is the negative flag go true? Well, 8, 9, 8 has a 1 in the most significant bit. F0 has a 1 in the most significant bit. That's why it's considered negative. Now 27, there is not a 1 in the most significant bit. So we're watching the simulation. We can always start single stepping again. Okay, let's get rid of the breakpoint and let's say run. And now you don't really see anything because it can't show you the values quick enough, but you can always pause it with this little pause button. Boom, pauses it. And that, now we're back to this, well, we're at this point right here. Oh, because eventually it found the value of 0. So we got out of that loop. You may have run this 10,000 times by now. Okay, let me show you a couple more things. Let's go back to Project Explorer. let's look at the ROM MIF that it created. So let me stop that. Okay, ROM MIF. So it made a ROM MIF just like you're going to make for Lab 6. And it put the machine codes and in comments the instructions. So LDAA 37, LDAA 37. Where did that go? That went at location 0, 0 and 1. And location 2 was the LDAB 37. And so it shows you the exact machine codes. I want you to know how to do it yourself, because in your lab quiz and on your final, you're not going to have this G-IDE to use. You need to know how to do these yourself. Now, making the MIF file isn't as important as doing the hand assembly, but this not only did the hand assembly, it also shoved it in a MIF file in proper format. And it also made the RAM MIF file. And the RAM MIF file doesn't have anything in it. We're not starting with any data in RAM. But anyway, pretty cool. And in fact, you could supply this, instead of starting with an assembly language program, you can actually start with the raw MIF. And from the raw MIF, you can actually run. So here, I started this by showing you a solution that I'd already made. I'd already made the project and the solution. Now I'm going to make a new solution. And for this solution, I just clicked on that and a little window came up. And I'm going to make a name for this. I'm going to say phone number. And what type? And again, I can make it a MIF solution and supply a MIF file. But I'm going to say assembly solution, create. And over here, it just closed this G-IDE full. And now look at that phone number. You click on it, go over here, click on this, and it's empty. Well, what I'm going to do is take the example I wrote before. I'm going to cut and paste. I'm going to cut it and paste it. So I'll have to rewrite it. Now notice there's some color coordination done here. Whoops, I didn't do the right thing. I didn't do the whole thing. There it is. That red showed me that there was a mistake. Okay, so here I just copied all the code. So now, in theory, I should be able to just build it. And that's called build assembly. That's typically called, come on. It says build assembly. That's called assembling the file. Let's do it. I just assembling, no changes left. Oh, what it just did is it built the wrong file. Remember how you do top level entity in Quartus? I've got to tell it that the phone is now the top level entity. And so I just click on phone and say set phone as top level entity. Boom. And now when I say build, it's going to build this. Come on. And it built it. And so, hey, it just built phone num. And, okay, it built phone num, and it made a ROM and a MIF. A ROM MIF and a RAM MIF. Let's click on this again, and let's look at the ROM, the MIFs. So this ROM MIF shows the machine codes. Let's share this with what I had before. And let's look and see those values. Look at that 080001. Here's the 080001. So this compares to this. The one, I made a mistake here. What's wrong here? Oh, I'm missing a column. It says 01707. Here it says 0207. LDAA pound num. LDAA, ooh, 02. So I did it wrong. Good. So it showed us the mistake I made. So 02, there should be an 02 here. So even I don't get 100 on my own exams. Okay, then 0E, 00. Looks like everything else is good. Even the end, the address 10 is 20 and 10. Okay, so very cool. So it's run. Now let's simulate this. See what this telephone dialer thing does. Let's go back here and simulate. You say run. Again, that little button right there. It says start, which is run. It grays everything out. I'm going to go over here and say register Explorer. Shows us A and B and X and Y in the status base. Notice the 0 flag is already set. Why? Usually when you reset, when you run it for the first time, everything's reset. A is equal to 0. That's why the 0 flag is set. Notice the program counter is equal to 0. If we're ready to run the program, see how it's highlighted that line? So it's ready to run the 0th line. Where's that address? Org 0. So again, let's step. So here's the step. So the step. So now LDX phone. And let's go over here and let's change these guys. And here, let me write dialer. And what else do we want? That's really all we want. Need the rest of this. And okay, so phone number, I just loaded X with the pointer that is phone number, which is 100. So let's see, X is 100. Look at that. X is 100 up there. Okay, and so then I'm going to run this LDAA pound num. And so after this instruction, the A is now 0. It should be 7. So I'm going to say step. And I believe now something that you can't see, I don't know if he's ever documented this, but I believe F11 will single step. Function key F11. Let's try. It did. So there's something to know. F11 single steps. And I'll tell you another function key later. Okay, so anyway, we're ready to run the next line. So let's see, A is now 7. Now we're reading the first number in the phone digits. So right now, X plus 0 points to the 3. So let me show you something I haven't shown you before. Down at the bottom, it says build report. Let's look at memory view. Here, I can look at any memory location. In fact, if we look at the first address, 0, I see the 080001, 080001, 080001 is at location 0. This is kind of a viewer of the memory of the, in this case, the ROM. We'll look at address 100, and I need to put the $sign at the beginning. So address 100, because at 100, I should have 392.2541. Look at that, 392.2941. Okay, there's the phone number, but I can also put it at dialer. I think I can just write dialer. Yes, I did. I wrote dialer, that word. And again, case doesn't matter. And dialer is 1701, and so here's address 1701. But I've got it up here too, so let me not do that, and instead put this back at 100. Okay, so now let's continue to run. Let's see. So now X, well, B should have the first value, the 3. So B has the 3. Now I want to store that 3 to dialer. So we're going to see after the next step, dialer will have that memory location with value 3. So let's step. Look at that, it's got 3. So now we're going to increment X. X right now is 100. It should go to 101. Look at that, it's 101. What's at location 101? The 9. This 9 right here is at 101. But at this point, we want to subtract 1. So B is going to get a -1. So let's step this. We hit F11. And so B is now FF, -1. And so we're adding -1 to whatever was in A. A was 7. So after this instruction, A should equal 6. And now A equals 6. Look at the 0 flag. It's not highlighted. So that means A is not equal to 0. So this branch is going to end up going back to loop. Let's step, and it's back at loop. Now I'm going to put a breakpoint right here at the I and X. So I'm going to run to the breakpoint, and I believe that will be F5. Yes, F5 will run to breakpoint. So now the dialer should have changed its value. So I dialed the 9. I'm going to hit F5 again. It dialed the 2. F5 again, another 2. F5 again, the 5, 4. Now I'm going to step through the rest of this. So I've just done the 4. And so now I got one more digit. So I'm going to, what's in A right now is 2. I'm going to decrement again. It's going to be 1. So now it's 1, so I have one more digit to dial. So I'm gonna go back, read the last digit, which was the 1, send it out. Here's now a 1. Increment X again, which I really don't need to do, but I did. Subtract 1 from 1, and now look at that. A is equal to 0, the 0 flag is set, in the condition code register, the 0 flag is set. And so when I get the branch not equal loop, it's not going to take the branch. It's going to go to the next line. That step. So I get here and it says branch equal here to here. Well, the 0 flag is true, so it's never going to get past this. So I keep hitting this single step, or I keep hitting F11, and you can't even really tell I'm doing it. But I am. Click, 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 click.